So force per unit area, right? And Newton per meter square or 1 Pascal, right? 1 Newton per meter square is a Pascal. Can be erected. This can be erected, disassembled, moved, and re-erected rapidly using proper handling equipment and available, right? So it's easier to handle, easier to move without breaking, right? Even if you are rushing, it is still handleable, no chance of breaking, right? It can be moved easily, handled, provided you have good workmanship. Care should be taken only for carrying the weight. Other than that, it is free to move, it is free to handle, free to fix, right? And then leakages can be avoided, right? No leakage because there is no free with the, like this type of bending that you have seen in your in wood, right? Sometimes bend, sometimes swell, sometimes honeycomb. All these types of problems won't occur that much easier in metal compared to wood. So leakage can be avoided. No shrinkage due to temperature change, right? It can withstand temperature, so it is not susceptible for temperature changes. Easy to fix the joint with bolt and nuts, right? Once you form the work, right? Once you construct the formwork, it is easy to fix at the connections by bolts and nuts. Did you anyone go through the links that I provided in the slides? Are you going through? Last every slides, at the last slide I provided the links for you to learn more about this topic, because this 1.5 hours is not enough for you to learn. Answer me. How is it? Yeah, answer me. Did you go through the link or not? Did you see the link or not? Hearing me? Are you there? Are you there?
No, miss. Not
But
yet.
do you find the links there? You didn't see it, huh? Please do it. Please do it.
Yes, miss.
Because when you go for next thing, when you go for co-op or any other type of what do you call training, you will not have enough information, you will not have enough knowledge. This 1.5 hours and the test and exams will not give you complete information, complete knowledge on this module. Okay, it's for you to go through and learn more about the subject. Okay, right. Okay, Abdul Rahman is here. Abdul Rahman is.
Yes, sir.
Can you tell me what type of pins and bolts that you studied in the last class? Pins and bolts for forming the formwork, right? Assembling the formwork we use, right? What pins? Jack pins. Remember jack pins? Any other? Remember these terms, la. These are all English new terms. You must. It is also taxing your remembrance, right? It's all knowledge. The whole program is for giving knowledge and the information on this subject. It is not designing. It is not drawing. More vocabularies and terms are involved. Okay, so the joints and bolts and nuts, different types that used in the last class that I showed, can be repeated for these metals. Economic if there are enough reuses. Okay, I will go to that part again. Don't worry. Let me finish this one. Economic if there are enough reuses, right? Because you are using one number of times, you don't have to buy. The cost of buying formwork or replacing formwork will be reduced. For load bearing wall and shear walls, mainly it can be used for load bearing walls and shear walls. Okay, where yeah, the huge construction like pillars, right? The piers, the columns are constructed, and the walls which is going to support the whole load from the superstructure will be constructed using metal compared to timber. Limited to shape of the structure. Disadvantage. The steel formworks, they are all it is easy, not that much easier compared to timber to customize, to adapt, ADA, adapt to the situation given, the structure given. You need to cut it, very difficult. Otherwise you will be using more than it is required, right? The height and the width and the depth, everything have to be according to the, you have to choose and according to the particular construction. So limited shapes. Standard steel unit or too heavy and difficult to handle. Yeah, that's why workmanship, if the work, it needs a high workmanship, right? Heavy loading coming in addition to the other types of loading, you need to consider during construction. Metal formwork, the one of the metal is the aluminum, right? It can be aluminum, iron, any type, but the most commonly used one is the aluminum due to rusting and also easy handling. They prefer aluminum against wrought iron or other types of iron. Selection of type and grade is important. Okay, this code also I mentioned last time, right? Remember the number? All the specifications are available in this code, right? Specification for you to choose the type of uh, this code. You can see the code CIS 23 has all types of materials, all types of standards and the sizes and what type of structure it will go in. I want to inform you one more thing. I think I uploaded, yeah, I uploaded already amended final version of your teaching plan and also the course outline. Okay, wherein I have given the building bylaws, right? Building bylaws, uniform building bylaws, UBL. Can you all go through at least once? This is the Bible of all types of constructions, norms, standards, right? Standards, sizes, norms, the criteria, types, all these things are available there. Sometimes I may set question from there. I will take the topic from here, but take the material from there. It is the Bible. I say it again. It is a Bible of any construction engineer at site. Okay, I request you to read. If not, you remember many things, important things, the repeated, common, the typical structures you need to remember in your mind. That time cannot go on refer. That's not fair. These are all, most of them collected from UBL only. All the information is copied from there because we, as engineers, we strictly follow those standards and norms. What are the criteria given? What are the types given? Sizes given? You need to follow. Depending on the structure, depending on the climate, depending on the material, it will be varying. Okay, where we are? Okay, limited. Name. Aluminum formwork. Due to degradation and corrosion when subjected to marine environments, needs special release agent. Okay, these are all the aluminum. It may mean due to degradation and corrosion when subjected to yeah. Aluminum is good. It's not that quicker in getting rusted, but at the same time, when there is a salt water, marine structures, chemical structures that you are building, any type of chemical related works or any type of marine related structure will have a contamination by salt or in chemicals may affect metal formworks, especially aluminum. It will start reacting. Aluminum will start reacting. Aluminum is positive or negative? Quick, 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 quick. Aluminum is positive or negative? Cation or anion? You have to remember these things. Aluminum is cation or anion?
Cation.
When it contact with the anions, start reaction. Okay, all types of reactions end up with unwanted materials, losing strength, losing material, and so on. Okay, need to suitably construct, choose, and then use it in the site. Needs pressure release agent. Okay, yeah, in this case because to avoid all these problems, you can coat it, you can apply any initial solutions before you start using it. Glass fiber reinforced plastic. Plastic is not the right word, like polymer, huh? Polymer. It's already polyester is there. Huh? But reinforced plastic, still okay. Strong and lightweight, okay. They are using glass. The glass is again brittle in nature, easily broken. To avoid that, they reinforce it, strengthen it to construct formwork. So glass fiber reinforced, glass with reinforcement, together with the reinforcement like the one I photograph and I see, not this one. I'll show in the video later, okay? I have shown you in the beginning, very beginning, the glass fiber one, okay? Remember that one. So reinforcement it is pitched with all the reinforcements at irregular intervals so that the strength is increased. A combination of 1/3 fiber to 2/3 plastic are used. Almost 1/3 of the fiber will be replaced by 1/3 of fiber and 2/3 of plastic. That's why it becomes a polymer. Comprises of polyester resin reinforced with glass fiber. In addition to that, it is also having reinforcement. Strong, lightweight with long service life, capable of producing high quality concrete with unique shapes. Because it's polymer, you can bend it, you can prepare it any different shapes. Lightweight, stronger, durable. Thickness varies from 5 to 6 mm. Can be used more than 100 times. See, the last one metals are 30 to 40 times. This one 100 times if handled with care. Disadvantage is similar with plastic formwork. Okay. This is an example of plastic formwork with the reinforcement. See, these are the rods, reinforcement rods. This is the fiber. Okay, fiber formwork. They are using this truck, the crane, the crane, zigzag type crane, and they are preparing the reinforcement, or they are forming the. They are assembling the formwork for construction of this dome. Okay. This is another type. This is another type of formwork using metal formwork. They're going to use it for pouring concrete, maybe a column or any slab. After this, let's go through this aluminum type of. Can you see this? Here, this is one good example of aluminum used in formworks. How conveniently they are used. This is most common structure in day-to-day life. One moment. Okay. You can hear you can learn from this one. One moment. Okay. Can you hear? Is it audible?
Yes.
Yes,
Miss.
Globally renowned Doka-Deck 30 panel floor formwork.
Okay, the Doka-Deck 30 system we've brought into
Doka South Africa introduces the globally renowned Doka-Deck 30 panel floor formwork.
Okay, the Doka-Deck 30 system we've brought into South Africa because we see the need for a modular, lightweight system. There's not many components. We've kept them down to a minimum, which obviously makes life easier for labor. It's simple to erect because there are such few components, and it's easy to erect because they're so light.
The routine is simplicity itself. Fetch the Doka-Deck 30 panel, engage one end, swing it up into position and prop with floor prop. One system with only 3 basic components: panels, heads, and props.
There's always training required in any system, doesn't matter how simple it is, because you have to concentrate on the safety aspect as well. But generally, because it's almost, it comes in kit form and it's just components that click together, if you like, and you don't have to use a measuring tape or anything like that, it just makes it that much easier for unskilled people to use. There's always a certain amount of measurement. You have to have a starting point, and you're working off a drawing. But the thing is, because we're using fairly large panels, you're putting up quite a lot of formwork in one hit, if you like. It's easy for 2 people to pick up even the largest panel, which measures 3 square meters in area. So you can appreciate that 3 square meters at a time is a big saving in work output. Well, one of the safety features we have is that the large panel, which is sitting on two galvanized steel props, there's an anti-dropout device that's built in, so they cannot the panel cannot drop down on its own. It has to be lifted up and then moved away from the props, which ensures that there's not that danger of something falling on anyone.
The Doka Deck 30 is geared towards the rough terrain of Africa, and construction companies will be surprised at its efficiency and its cost effectiveness.
At first glance, the system looks as though it might be too heavy, but it's not. The second thing is there is a pricing factor in it, and we don't claim to be the cheapest in town. But what we do claim is that if you use the system, you will become one of the cheapest in town because of the savings in labor and in maintenance. I keep coming back to the stock phrases from Doka, which is safe, fast, and efficient. You'll work safely, you'll be extremely fast, and because you're efficient, you should make money.
You've just seen the advantages of going for a Docker system. Is a brand that they are using. Okay, by that they are also explaining how easily it is handleable, right? How strong is it? How repeatedly they can use it? Am I correct? And the fixing also easier. Assembling and the fixing is easier because it can be folded, right? It can the polymer, the Doka system, the plastics, they can be folded, they can be connected to the column easily, the joints can be fixed easily, and dismantle. Mantle and dismantle is assembling and dismantling is much easier, time consuming, and provided you need to give proper training, isn't it? Right. There are many advantages in going for these types of plastics. Plastics. Doka system example 1. Right. Defects in formworks. Already. Main defects in formworks of these types are blowholes, uneven color, right? Small holes less than 50 mm diameter caused by trapped air between the formwork and the concrete base. Yes, you need to properly, because it's plastic, right? Tend to bend, right? As you keep on loading, when you really go into the site, you will encounter a number of troubles. Learning and understanding is one thing. When you go to the site, you really have to apply more of common sense than technical. Technicals needed, but common sense is also important, right? Before you see whether this plastic can hold this much concrete or not, that understanding should be there, right? You cannot simply load it, right? And then if it is heavier, if it is not matching, automatically there will be a little bit bend or leaving a gap between the formwork and the concrete. Say for example, some which can entrap the airs, right? Which can allow air, causing difference in shape, difference in settlement, right? Affecting the settlement, affecting the strength of the concrete, and so on. Uneven color caused by irregular absorption of water from wet concrete by the formwork material. Yeah. This is also another issue in terms of these plastics and polymers used in place. Sometimes if it is so hot and temperature is very high, right, and prolonged, right, like with the curing, you leave it for 24 days and so on, there is a chance of decoloration of the plastics, decoloration of the formwork, yielding the color or depositing the color onto the concrete or onto the structural members which we are constructing. So the care should be taken in this case, whether it is, check before you use it, right? How often you can use it, how many number of times you can use it. Soon after it is to the extent that it started melting, yielding, right? It is called yielding, or separating, depositing colors, depositing some stains onto the concrete. This has to be avoided or replaced with a new material. So these types of troubles are there in using polymers and plastics. Another defect, the defects in diagram, you can see the holes Improper settlement. When you pour the concrete, if the consolidation is not uniform, they are perfect, it will leave holes like this. If small holes, okay, acceptable. If big holes, and number of holes, imagine big holes with number of holes, automatically there is a way for developing honeycomb, developing home for insects, right? Insects. At the end, you will be spending more amount on the plastering, finishes that you are going to apply onto it, and then ultimately the strength of the concrete is also questionable. Concrete that you made. So avoid these types of blowholes, right? Blowholes, and this one sometimes like this, a patch of small holes also. It's not is or you cannot avoid it, but you need to identify and rectify it immediately during plastering. Uneven surface, this is also another thing. This caused by removal. Maybe they use the steel formwork. See here, you can see the rusting kind of things, and then the because it is the inside formwork is not properly applying the resins or apply the coating, it may lead to all these types. Sometimes some portion got removed nicely, some portion left here removed, here uneven, totally uneven. This concrete has to be, this is peeled off, right? The concrete is peeled off. Here some concrete, here also peeled off. Instead of having uniform concrete surface like this all through, this material is removed, this material is removed. It might be number one, the coating inside the formwork is not properly applied or not of good quality, or the way they remove the formwork is not proper. Okay. Otherwise, the form settling time, they didn't allow for settling time. Maybe easy, quicker removal, early removal of the formwork also can cause like this. Surface treatment. Okay, this is important thing. How to rectify all these types of problems? The uneven surface, blowholes. What else? Yes, learn. Rusting. All these types of rusting, uneven holes, uneven surface, blowholes, honeycomb, right? Types of release agent to avoid defects. How to avoid all these defects? Yeah, to make sure that the neat oil with or without surfactant, right? The oil with surfactant, there's additional surfactant admixture, we can say, no, not admixture, coating. Surfactant coating will be helpful in avoiding these types of blowholes and honeycombs. Mold cream emulsion. There are a number of products in market, right? Buy the good quality product, right? Make sure that it is, they read the label. As engineer, you should not simply buy and send it. Like when we buy things for home, we will always check for the expiry, the items inside, ingredients inside, isn't it? Similar to that, you should also take care of the building that you are supervising or managing, or you are executing the structure. Check the label, what is written, what are the chemicals, what are where you with which you're going to add, whether you're going to add with the mortar, we're going to add with the concrete, or add with the other materials, building materials accordingly. That's why you should have some knowledge on chemistry, right? Chemistry, which will react with what and what will be the byproduct. Some knowledge on the chemistry has to be remembered. It's lifelong. A chemical release agent. I want to use these types. Then wax it. You can use wax to avoid or have a proper clear surface between clear and very thin surface between thin straight surface between the formwork and the concrete or the member, right? So that you can easily assemble and dismantle it. Barrier paint, you can also use paints. Water phased emulsion. Water phased emulsion also easy to apply, easy to remove. These are the types of agents that you can use it for proper removal, avoiding blowholes, uneven surface, and so on. Causes of formwork failure. See here, inadequate bracing scaffolding. Yeah. Start with number one is causes of formwork failure. Right? Where are the formwork fails? What are the things that you have to bear in mind? Inadequate bracing and folding. What is bracing? Supporting members. Scaffolding, I will do it later. I mean, next chapter will be on scaffolding. Formwork is the containment structure that you are using, and these structures, if it is at high level, if it is on ground, no need of scaffolding. If it is above ground, maybe first floor or second floor and so on, you need a supporting formwork, supporting column, that is called scaffolding, right? And this scaffolding has to be connected by bracings to support the formwork at some high level. More frequent causes of formwork failure: inadequate cross bracing and horizontal bracing of shores is one of the factors most frequently involved in formwork accidents. Here you should have as an engineer, you should, because you all graduate and then you go for construction work, right? In that case, you should have knowledge on the shearing, right? Shear, where the member will show shearing failure, where the member will show bending failure, where the member will show torsion, rotation, and so on. Right? This is simple knowledge. Even the what layman, uneducated people, the well-renowned masons, they themselves have come out with very good formworks and structures built by them. Why not us, right? So you have to make sure that they have proper bracing. Don't support it irregularly, inappropriately, right? Unnecessary cross bracing, or not provided enough bracing wherever it is necessary. Like if there is a horizontal necessity, you have to provide, and cross bracing, if there is a necessity for between these two, you have to provide cross bracing to support. If it is a whole structure, you need to provide a cross bracing between columns. All these types of necessary structures and assembling should be there for proper completion of the concreting, completion of the formwork. Okay. Causes of formwork failure. Next one is vibration. Number one is the improper bracing and scaffolding, right? If this is shaking, scaffolding or the formwork is shaking, automatically the contained concrete, the concrete which is poured inside the structure will be in trouble, will be questionable. That's why you have to make sure that the formwork is firm, clear, so that all the requirements are always remembered. Three, I can classify them three types: general one, specific one, main requirements of the formwork. Always remember these 7 points, 7+ points in your mind, so that you can make sure that you are constructing a proper temporary structures for construction of the site. Vibration. Second one is vibration. Yeah, the vibrators. Forms sometimes collapse when their shores jack or displaced by the vibration force. Yeah, it is not only pouring concrete; it has to support also the vibration, because you need to properly consolidate. Right? When you pour the concrete, keep on pouring, you cannot forget consolidation. You cannot forget the vibration. They better I bring you the video. Sorry, I only by video I can show. I cannot take you for a site visit or any demonstration at the site, a laboratory. I thought of doing a demonstration, but let me complete the syllabus first. Vibration, right? After pouring concrete, they will put the vibrators inside, right? Else like a pipe, they put the pipe inside, switch on the motor, it will rotate. It will vibrate inside, so that it will have a thorough mixing of the concrete, get end to end. It will spread all over the surfaces, clear surface, fill up the material properly into the formwork to form complete structure of the element. Where is it? In that case, you should account for this vibration, not only the structure, the loading that is coming in, and also the vibrators that is used for consolidation of the concrete. So this loading has to be taken into account. If this is not considered, and this is yielding for the, if your structure is yielding for this vibration, automatically there is a poor outcome of your concrete structure. Passing traffic, movement of workers and equipment on the formwork. The effect of vibrating concrete. Number one is the jacks shores which are used for connections, right, have to be properly fixed, withstanding the vibration. Next one, passing traffic. When the people are moving, automatically it stops shaking, right? We should bear this shaking, this dynamic loading. The movement of the workers and equipments on the formwork, right? When the people are moving, when they're carrying People may sometimes there's a people movement or with concrete, with pans and concretes, or sometimes the crane lifting the concrete and putting on the floor there, on the formwork there. All these types of changes in the loading, dynamic changes have to be incorporated in your design of formwork. Lastly, the effect of vibrating concrete. Okay, effect of vibrating concrete. The vibrating concrete, number one, it will start mixing at that point of vibration, and also causing movement. The concrete, soon after you pour, it will start moving to the corners of the, moving towards the walls of the column. Say for example, it is column, and also moving the material, right? So internally as well as externally, those vibrations caused by the vibrators, people moving, and then all other types have to be accounted by the supports, joints, and panels or the members of the formwork with which you are assembling. Okay, next one, unstable soil under mud sits. Causes of formwork. A third one is the unstable. Number one is the bracings, problem of scaffolding, bracings. My experience also, but I don't have time, much time. You see here, starting, it is not only at the top, starting from the bottom, you must check from the bottom. There is, forgotten those things. The engineer will come to the side, engineer will come to the side after formwork, the engineer will come to the side, he will check one by one, column by column, you need to check what is the the bottommost, how they form it. So you can even shake it and check whether it's strong enough, right? How depth they have gone in. If it is mud sealer, put into the mud, or if it is a plate, steel plate, how hard it is. Just shake and check it. Gently shake and check it whether it is firm or not. It is susceptible for the light load that you are applying, right? And sometimes if it is a residential building, a small scale buildings, they just put all the stones, they stack it on the stones, and then they put it on over the stones, brick stones or some kind of gravels. They use it to support this formwork. In that case, it should be firm enough, transfer all the formwork loading, including the concrete loading, to the seal there, the bottommost plate there. So check every footing for foundation, the bottommost portion, and also the joints. Here it says bracing and scaffolding. So start from the bottom until to the top. You need to check. If anyone is checking, automatically your alignment of structure, the final product of the structure will be damaged, will be affected. Here, unstable soil under here mud sealer. If you are fixing into the mud soil, tug the soil, and then you tap the soil, and then put the columns or put the footings inside. Put the frame into the soil. Formwork should be safe if it is adequately braced and constructed so all loads are carried to solid ground through vertical members. Okay, you must fix it firmly, right? So that it can transfer its own load, dynamic loads, concrete load, and number of floors that is coming over. Side drainage must be adequate. Side drainage must be adequate to prevent the washout of soil supporting the mud seal. Yeah, sometimes they construct the scaffolding. All the formwork scaffolding finish. They are about to do the concrete next day, but raining. It will be raining heavily. It's quite common in cold countries, cold region, and also in tropical region. Sometimes we cannot predict there will be a heavy rain, heavy downpour. You will have a problem of these types of scaffoldings, right? All will be swallowed by the water. Once there is a heavy rain, you know the consequences, right? The soil structure will get loosened, right? Allowing stagnation of water at each and every pole. Sometimes you cannot immediately go for concreting next day, right? Either you make it dry and then go for 2 days later, or check whether you pumped out all the waters at each and every pole, and number one, at each and every pole, every supporting scaffolding, and then check once again whether it's stronger enough or not, and then go for construction. Drain the water due to rainfall or any other type of leakages if there is. then go for formwork. So it might be one of the failures reasons for poor workmanship at the formwork or any type of concrete construction. Let's see the parts. Sometimes I may ask this question in the exam. I give the structure, I ask you to mark. I don't give the exact this structure. I may take snap photograph of any structure in Cheras or Klang or Kajang, post it to you. You need to mark. Alright? I don't take from any website. So I take the real structure, you need to mark the parts. For that, please make sure you clearly understand component parts. It's mainly to communicate to the worker there. Alright, it doesn't mean that, and if you are working in the UK or any Western countries, you may communicate in English, right? For that, you should know in English first of all, and then you can translate to the country language, right? Mother tongue, that particular country. If you're working in France, German, Spanish. Spanish is more common. Spanish and French is more common. You need to translate. Otherwise, you can just use English. So try to learn in English terms. What are the component parts of the formwork, right? Start from maybe this. The diagram also very clear, I think. Number one, start from mud sill or base plate. Then the bottom was here there is maybe mud sill. They have a same mud, packed mud. On top of it, they put the base plate. It's a plate, steel plate, any metal plate, and then the pole, the scaffolding starts. And this is access ladder to go one level to another, climb to different levels before the member is actually constructed. Here they are going to construct the roof. Okay, they are going to construct the roof. For this, they do these types of all these types, and then the column together with the column, right? Column and just a roof and a column, 4 columns might be. So need to, how do you do this? You support this to construct this roof. You must have a bottommost foundation, proper foundation, raised by the poles, and then you have what is called access gate, right? Access gate, and this is called fully planked. This is the plank, bottom of the panel, this one, plank, the board, and then guard rails, maybe 1, 2, or 3, 4, any number depending on the height. Guard rails, guard means you can hold and move. Guard rails, toe board. The bottommost one will be very fully planked. Oh, the panel, each panel is called a plank, and the total, the bottommost slab is called toe board. It's called toe board. The bottommost, the slab, the whole slab is termed as toe board, and each one is, it may be using different planks, 3, 4 planks or single plank might be. But the slab, the bottommost panel which is going to support the slab will be called as toe board, and this is bracing. Okay, bracing across the columns, supports the columns, put the slab together, uniformly distributed, right? And these are the bracings to support these columns across, and then cross braces, if it is horizontal braces, cross, then cross braces. What else? Here, plumb vertical. The olden days they used plumb bob to check how straight it is, how vertical it is. There will be a mercury indicator moving on. You might use it in laboratories and later on. Nowadays a laser pointer is available, but olden days they used plumb and bob. They just hang it. When I was supervising the site, I used plumb bob. So they use the plumb bob to make it a straight line. These poles to be straight, otherwise you will have tilted columns or slabs built. So you should make sure that the columns are straight. That's why it's written as plumb vertical. Should be vertical. And then what else? That's all from this diagram. Just showing the site. One site with all this formwork for construction. Maybe this might be a railway line, or a LRT line or MRT line, because it's super passing, right? Maybe roadway, but I cannot say roadway. It seems like a station, constructing a station. That's why I can say this is a railway line with a station here. All the formworks for supporting this column or construction of this column for the. See the crane. Crane is in operation for continuing in constructing this. Maybe it's carrying this way. The building is hidden here, taking the cubes from here. Maybe building. See the reinforcement. The reinforcement structures need to be worked to properly position and construct the slab. Types of formwork. Let's continue with types of formwork. Last time the types of formwork is due to the material. Answer me. What are the types of formwork due to the material? Don't sleep. What are the types of formwork due to material?
Timber, metal, and
Metal.
polymer.
Polymer. Only I hear the answer from girl and one boy. I need to know who are they. What about rest? 33 are in the class. How many of you joined the class? Please make it interactive. If you feel boring, I stop and do some games. There are nowadays many different types of learning gadgets. We must explore them to the extent possible so that there is a learning, there is a perfect learning taking place, right? 3 people are missing today. Every class I see the 3 people. I need to check, and there are some student numbers and names and students. I personally contact them about their attendance matter, right? You need to give the reason, exact reason for the failure of attending classes. I will cross check with IR and then give you attendance if it is realistic and you provided sufficient evidences. Okay, don't go at the last day requesting for attendance, requesting for unbar and so on. Okay, come on, let's continue with the slide. Where is my slide? Okay, now materials, you very good, you classify it. Can we now classify based on the structural elements that you're going to construct? Okay, based on the structural elements also you can classify the type of formworks. Here they are: foundation formwork, column formwork, beam formwork, slab formwork, wall formwork. Right? You want to construct wall, you can use formwork. The name of the formwork is called wall formwork. Climbing formwork, right? Maybe a ramp, climbing a ramp or a staircase, sliding, right? Sliding might be for lift or for any winches. Permanent formwork. Formwork might be permanent. We will see what are they. Any questions so far? I insist once again, you need to do 2 homework because you don't have a next class. Thursday is free. 3 homework. Number 1, giving feedback, right, to improve how you want these classes to be going on. You want more videos, more slides, or I need to go slowly. I can go faster. You need more tutorial classes and so on. You please right now tell me, right? Because every cohort is different. There is a generation gap. Unless you speak out, we do not know what is your need. We have our own style of teaching, but we can adapt and we can change and provide according to your need. Okay, and you need to do 3 things. Number 1 is giving feedback. Number 2 is going through all the videos I have posted. Number 3, go through UBL, Uniform Building Bylaw. I post the PDF to you. Today I posted about 200 pages, I think. You can go through. You quickly can read in 1 month time. Okay. All right. Just read. First, read first. You will get interested automatically. Right. Where are you? Go ahead. Come on, let's understand one by one. Beam formwork. Okay, you can see. Beam forms must be designed and constructed to safely support vertically applied dead loads and vertically applied live loads. Okay, see here, this is the beam. Beam is a horizontal member which did I explain you how the load is transported? Maybe later when you go for building elements, you will do it. For now, understand that beam is a long member, maybe a slender, long member with smaller cross section compared to the length, right? The cross section is smaller always compared to the length, always provided in a horizontal direction. Horizontal direction, not vertically. If it become vertical, then called as column. Horizontal, mostly available horizontal, different shapes, it may sizes, circular, triangular, rectangular, square, any type. You can see the one example. This is the beam. See, beam. You're going to construct a beam of this length of this cross section, square cross section. They are building the formwork. Okay, let's understand this formwork and its component parts. How they are going to support this beam to construct this beam. Okay. Mostly this will come in the buildings, right? Surrounded by the walls, right? The beam may be surrounded by the walls, right? There is no column inside. The beam will be constructed and it will be surrounded by the walls. Further, it will be carried. It will be developed into different floors. Okay. Let's understand one by one. This is the slab form support joist. These are called joists. The pipes and the wooden members are called joists. Plywood sheeting for slab, plywood. This raw additional member, I don't ask this much, you draw and show me the parts like this, no need, but try to understand some terms at least. You can just say this as a supporting plywoods or panels or sheeting, right? Plywood sheeting for slab, maybe continued by the slab. This is beam, it might be continued by the slab, that's why they are having, where is it? Okay, they have a rectangular, square, long formwork. On top, they put the plywood to continue for construction of the slab. Okay, and the one, this is the plywood. This is also using plywood, and the material is plywood. But they are doing the material member is beam formwork. Plywood beam forms, beam forms. The forms that are used for beam construction of beam is called beam forms. And kicker, where is it? Kicker, and then T head. This is T head. This is T head, like a T, T junction. And this is the diagonal brace, cross brace. Just say cross brace also will do. Shore, the column that is supporting the beam is called shore. Last one, the sleeper, bottommost sleeping on the floor. Is that sleeping? Sleepers are the bottommost, the end, final load transferring member to the ground. Sleepers. Okay, next. So it is the purpose is mainly to apply the vertical. This is adding a vertical load of the concrete, dead load of the concrete, and also live load. People may be moving as it grows in terms of plots. People may be moving onto it to pour the concrete inside using cranes. All right, depending on the type of structure. See here, the combined one. They use metal and also polymers. See, metal scaffolding, and the polymers. These are all the plastic PVC for construction of. What is this member? Anybody? What is this member? Blue? Quick. What form is it? Name of the form. What is this member? What form is it? Name of the form. Blue.
Beam.
Good. Beam, all through the construction. All through the structure they are running beams at the corners. Inside will be slab, and this is the column, right? So these are the steel pipes or shores supporting or scaffolding supporting the beams. Cross brace, whatever the name you can use it. Nowadays they use it as angles, just angles supporting the because that's some angle, right? So angles supporting the beam formwork. and this is opening because they are going to put another one on top. Continue, right? See here, nice work. Foundation solutions. This may be, see, this is floor, right? There is a nice, there are plenty of videos online how a construction, so how a building is single is constructed in 10 days. What is the step-by-step construction of a building? What is the how much is the quantity? I mean, you will study later. I'm sure you will technically study in detail later, but have some first-hand information. Not like a layman, like close eyes and you're studying. You should have some background knowledge, right? More information packed. To do that, you need to go through more reading and more video. Nowadays, you are bestowed with many videos, ready-made videos, right? You can go through. Right. I will bring one. There is one nice video. You should all know in this module how a construction is started and ended. What is the very beginning of the? Hey, you studied in I used to show in the beginning itself. Like Ben was teaching your clearing surface, earthwork, right? Clearing the sides, earthwork. Did you go through that video I posted? There is a one nice video started from the foundation up to the structure, how a stage by stage work is executed in the construction. Do you all know that? If you know, answer me. What is this? I don't know what is this. Tell me. Wait, I call by name. Interesting. If you don't know, don't worry. You learn today. Oh, what is this gentleman? I need to take attendance. Hey, what's the time? Remind me. Keep talking. 6 o'clock. Answer me. I told you to switch on the camera. Nobody is switching on the camera. Doesn't matter. Where is it? Student. People is not here. Cannot be the people. In meeting 32. Ali, Yelding. Can you tell me what structure is it? Quickly. Ali Yelding. What structure is it? Times 1, 2 people I have given chance. Times 1 or Ali Aldin. Answer me. What is this structure? You can guess. Sitting on the ground. This man is doing something here. What is going on? This is all done for you plus time. Ali Aldin, slept already.
Foundation, the foundation or shadow foundation.
I have given turn to Ali Aldin and the name gone. Tanzwan. Is it
Miss
Sangeeta? Is it Sangeeta who is answering? The girl? What's your name?
Shan'an.
Sana. Tanzwan. Oh, sorry. Thank you. Tell me, what is this structure? Can you guess?
The shadow foundation structure or what?
Foundation.
Oh no.
Do you think foundation? You see here, you can see some construction here. What does it mean? There's construction already. Any other? You can give any name that you know. I will correct. Quickly.
Is it wall?
Wall construction. No. There is no flooring. This man is standing here, right? This is all filled with material for flooring. After flooring only you start the wall. Basement, okay, before you make mistakes, I correct it. Basement, this is called basement, fundamental structure or the basement which separates the wall and the foundation. Basement, plinth beam, plinth level, they say in olden days, a bit differing, the terms are differing and changing nowadays. You can simply call this as a basement, basement. It's a small construction, it's also wall construction. It may be a type of a wall construction. It may be stone, mostly using stone, not wall, not brick. If started wall, they use brick. Brick or concrete blocks can do. But this one is a proper reinforcement or otherwise stones, pitched with the stones, large size stones, gravels. This might be a basement or plinth level which separates the foundation or transfer the load of the walls into the foundation, right? Into the foundation. We can call this as a basement. He is constructing the basement structure, a tie beam. Sometimes they call this as a tie beam, tying together. Basement. These are the steel scaffold. In the formwork they use it. Inside got reinforcement. Maybe they are using the basement as a reinforced concrete construction. Okay, this is called reinforced concrete construction. For this he is using the formwork. Because it's concreting, he uses a formwork. Because it's reinforced, you can see the steel rods inside. If no reinforcement, it is not called as RCC reinforced. It is a plain concrete structure. They just mix the concrete, pour it. Have you heard about the concrete mixes? Different types of mixes. One is 2:4, 2:4:8, one is 3:6. One day I will teach on that particular material. Although it is not mandatory here, you will study in materials. You should know. I keep saying concrete, concrete. What is concrete? Answer me quickly. What is concrete? Before I go into all the grades. Again, if you read this UBL, you will know all these grades. Just an idea about. But you have to go for concrete code books for that. But you will use these types of code books left and right or every classes in RCC design. When you go for RCC design in year 3, year 4, of course you will always refer to that. The mold, the size, the strength, and the standards, all those things. Now answer me, what is concrete? I quite often.
Mixture of aggregate, sand,
Who
and
is, who is this?
Amli.
Okay. 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 Mixture of
Aggregates with sand and water, and then and cement.
very good. Say in order cement, sand, aggregate. Cement, sand, aggregate mixed with water according to the workability of water, right? I don't know where you will study this workability. There's another thing, consistency. You will study in soil mechanics or geotechnical engineering later on. But now understand concrete is a mixture of cement, sand, aggregate. Okay. If you don't know what is aggregate, I will bring pictures later. Aggregate can be of small jelly, small stones, small stones of 1 mm, 5 mm, 6 mm, 10 mm, right? Depends on the sizes. Different size types of jelly mixed with water. They sometimes they hand mix or concrete mixers will mix, and then they pour the concrete into it, vibrate it, settle it, right? Allow to settle, then it is called a concrete work, right? Just move on. Next is typical beam form work. Typical beam form work. You've done already, right? This part. Yeah, we have done already. Another view of form work. What else? Another types, not much important, but I try to understand that there is a formwork supported by the shore, and this shore is supported by T frames and the bracings, and there is a soffit support joist. Joist means wooden pieces. Joist wooden pieces, maybe a horizontal one or running in the other direction. Join the members which is joining the panels, supporting the panels. And thickness may be 21 mm thick plywood. When I say 21 mm thick, you should be able to imagine that's engineer. Okay, 21 mm, 2.1 centimeter. 1 centimeter you can imagine. 2.1 centimeter, roughly around 1 inch. 1 inch. 1 inch plywood. If I say, you should be able to imagine. If you're working in UK, you should know all the imperial units. What is yard? What is inch? What is foot? Feet? All these things should be thorough and able to imagine. Okay, next. Column formwork. This is column formwork, forming a column. They're going to pour concrete inside, maybe a reinforced concrete or a cement concrete, just any other material that they are using it. Where is it? How they form it? Beam forms are especially susceptible to large lateral loads. external exerted due to high rate of placement of wet concrete, right? They are susceptible for lateral, right? Chances of running this way, pushing the panel out, or lateral loading onto the formwork is quite common in beams. Now coming to this one, tighter joints and bottom lateral. This should go to that slide. Okay, no, there's a question. Tighter joints and bottom lateral support is critical for these types of formwork. Why? Tighter joints and bottom lateral. Here, you come to this one. Tighter joint. These joints should be tighter, right? And bottom lateral support is critical or crucial for these types of formwork. Why? Column, now we are talking about column support. So number one is keeping it in position, right? Number one is keeping it in position because the vertical loading is more, right? The column is susceptible or subjected mostly for a vertical loading, hence chances of lateral movement, and this lateral movement will be supported or reacted borne by these joints. So these joints will prevent lateral movement of the panel or lateral movement of the concrete in the column construction, and also bear the loading, vertical loading, transfer the vertical loading of the formwork and also the concrete. As the concrete is growing, right, as the concrete member is being built, the load will get increased. So it will properly distribute or disseminate the load to the bottommost plate or to the ground safely until the construction is finished, allowing for curing and then removing them. Okay. Example one you are seeing here, right? These are all the bracings, right? Cross bracings or angles are can call this as sword, and this is the support, angle support that is used. There is a separate name for that one. You want just see. You can just use it as a braces and cross bracing, and then the formwork with the different joints, right? Joints are most important to keep the concrete in position, bear the lateral load, bear the vertical load, and so on. You can then go through all these things, typical ones, and different component parts keep repeating, but different views. It was so informative, that's why I brought these pictures. You can go through, right? I will not ask all these things in the examination. This is for your knowledge only. You don't have to remember a lot, but understand the basics at least. Okay, when you apply, you should be able to answer why, what is the problem, why it has caused this problem, what is the reason, how do you fix it, and so on. Similarly, typical beam and slab formwork. You see here, beam, column. Sorry, beam, slab. Beam, slab. Maybe a roof, roof slab. Roof slab is like this. A beam, maybe this is one room, another room, separated by a wall, and this is another beam, another room. Okay, and this is the column. Lot of mosquitoes in the classroom. Okay. Any questions so far? In another doka, very interesting one. Actually, I admire many times, seeing this many times. You should also learn from these videos. One moment. These are the very new and which is in practice I brought down. So you need to go follow. I mean, go through. Where is it? Where is it? Where is it? Include computer sound so that you can follow formwork, right? Formwork. Okay.
Doka's slab formwork system DokaFlex is based on the simplicity of the very commonly used 4x4 system. The major difference between a DokaFlex and the 4x4 system is that we have increased the capacity of every single component. This simply means that we can now use the existing experience from the 4x4 system and increase the spacing between the members. This increased spacing will require less material than the conventional 4x4 system when used for the same slab area. Less required material means there will be less material to handle, less labor to set up, less labor to strip,
Can you see?
less labor to transport.
Can you all see the slide? Hello?
Yes, miss.
Can you?
I cannot see. Wait, I resume myself. You're following, right? Okay, sorry. Sorry, I continue. Okay.
Doka's slab formwork system DokaFlex is based on the simplicity of the very commonly used 4x4 system. The major difference between a DokaFlex and the 4x4 system is that we have increased the capacity of every single component. This simply means that we can now use the existing experience from the 4x4 system and increase the spacing between the members. This increased spacing will require less material than the conventional 4x4 system when used for the same slab area. Less required material means there will be less material to handle, less labor to set up, less labor to strip, less labor to transport, and less labor to clean. The four major concepts of the DokaFlex system are speed, simplicity, flexibility, and safety. To better describe these concepts, let's take a look at a few components that make the DokaFlex system simple, flexible, safe, and fast. First, let's take a close look at our post shore. All Eurex props are hot dip galvanized inside and out to inhibit rusting on the inside of the prop. This rust prevention guarantees that you will always be able to extend the inner tube to its correct height without having to pull it against the slab edge because the rust sees the two tubes together. This will also guarantee full load bearing capacity throughout the life of the prop. The inner tube of the Eurex prop has numbers at each hole location to make the pre-leveling of the formwork very efficient for all laborers. The pre-leveling of the formwork is accomplished by inserting the attached pin into the correct hole. Final leveling of the formwork consists only of fine judgment with the prop nut, which has a convenient handle to make final adjustments quick and simple. The load capacity of the Eurex 30 prop is 8,500 pounds for any floor height. The reason for this is because Doka has an important safety standard that rates the prop's load capacity independent of the floor height. This prevents the danger of overloading a prop due to the overextension of the inner tube and makes it simple for all people to use on the job. The removable folding tripod is what allows DokaFlex to become a one-man system. The tripod will independently support the Eurex prop during setting, adjustment, and stripping. This eliminates the need of a man to hold a post while the 2x4s are attached to set and brace the prop into place. The lowering head H20 is a 4-way head built specifically to support H20 stringers with an additional 2-inch stripping feature. The lowering head provides you with the option of supporting one stringer, or by rotating the head 90 degrees, you are able to support 2 bypassing beams or a double stringer. When erecting the formwork, only the initial main props, which are spaced every 12 feet, require a tripod and lowering head. Then these props that are spaced every 12 feet are the only ones that require adjustment in order to level the system. Once the main props are supporting the stringers, you can begin leveling the deck. One major advantage of DokaFlex is the possibility of leveling your deck long before you start setting the intermediate props. As a result, you have a minimal amount of props that need to be leveled in the beginning stages of erection. The H20 Top P is a lightweight timber beam that has been engineered to allow you to cover large spans. Having a built-in shock absorber at both ends, the H20 Top P can withstand normal job site abuse and provide you with a timber beam that has a long lifespan. This system's stringers and joists are both made of H20 top Ps. The stringer and joists are both interchangeable, which provides you with a very flexible system consisting of only two beams. The two different beam sizes are 16 foot and 11 foot 6. These two sizes will be able to accommodate almost any job. With the addition of the 6 foot or 1.8 meter beam, you will be able to cover every job application that is possible. Two different beam sizes make it very easy to identify which beam is needed by calling for the long or short beam. There will be no time wasted looking for one specific beam length. Simple, fast, and efficient. Once the setting of the joists on the stringers has started, a crew of men can follow the setting of the joists and set the intermediate props every 4 feet between the main props. The carpenters do not have to wait for the intermediate props. They can start laying plywood once the joists go up. All intermediate props have a special clip-on supporting head. The supporting head design allows a quick and secure attachment to the end of the Urex prop. Attachment to the stringer requires no nails. All that is needed is a twist of the prop, and the supporting head is secured around the flanges of the beam. Independent from the floor height, all intermediate props can be set or stripped without the assistance of a ladder. After explaining all the components within the DokaFlex system that makes it fast and safe, I would now like to talk about the flexibility of the system. The word flexibility means that we can use the DokaFlex system for all slab projects possible. When forming the required slabs, there will be no need for longer beams, shorter beams, or different panel sizes. DokaFlex will simply adjust to every layout or slab thickness by simply adjusting the overlap of the beams in two directions. With the stringers, it is possible to overlap beams because of the different capabilities of the lowering head, which has the possibility of supporting two beams. With the joists, it is also possible to overlap the beams because of the simple fact that they are resting on top of the stringers. To make the system flexible in the field, you will have to overlap beams more or less depending on the requirements of the job. The joists can be used as stringers, and the stringers can be used as joists. But we always use the same pieces on all jobs without cutting or changing the material. This will allow you to adjust the slab formwork to any shape required and any slab thickness as possible by increasing or decreasing the spacing in between the members. Slab formwork cannot be any more flexible than that. This flexibility allows the contractor to start stripping and setting at any given location on the job without being limited to specific areas anymore. All components of DokaFlex can be easily and safely moved in transport devices with bolt-on caster wheels or a pallet jack. When moving equipment to a new location, floor, or loading and unloading a truck, all transport devices can easily be hooked and lifted with a crane. This is just another example of the planning Doka has made to supply you with a fast and safe slab forming system.
Okay. As though you've gone to the site, right? You loaded and unloaded the material of Formworks. That's why videos are very important to learn, right? And you see, you can find in the slides, there's just not the video, in addition to the theoretical, general, specific requirements of the formwork, each company, they have their own design, their own excellent, cleverly made design, incorporating their own key factors of their formworks. And then like this Doka, they have simplicity, safe, flexibility, fast, many factors they have their own, right? So like this, you in future, if you become a manager for any factory company, production company, or engineer for construction company, you can think in this way: how efficiently, how effectively you can overcome the previous problems, how cleverly you can design your own formwork, building materials or construction, right? You must work like that. Now, second one, the same, another product, Sky Deck Slab Formwork. See here, they have the same type. The steel plate is there, and the sword is there. Sword with some steel portion and some PVC polymer. I mean the plastic, steel and plastic. A combination of formwork is used here to support as a scaffolding, and then the formwork is for slab, using Skydep materials. Skydep, the supplier is a Skydep. The production company's name. Skydep supplies this formwork for slabs. Starting from fixing, how cleverly they made the fixtures without any additional joints or the nails and bolts. They just clamp it using a hook, adjustable clamping system, right? You must think in that way. You can partner with another mechanical engineer. You can come out with the best design for your own formwork, better than the existing one. That's how the technology grows. Striking of formwork. After all construction, how do you strike the formwork? The period before striking is depend on the concrete used, whether an exposure of the site, any subsequent treatment to be given to the concrete, the method of curing, and other factors. The spacing should be equal to 1 meter center to center. Okay, formwork. Okay, formwork. The extent, the spacing is also important for scaffolding. Later you will study. For formwork also, spacing is important, right? Spacing is important. Maybe the material with which you can go, how long you can go, how broad you can go, depends, shows the spacing of a formwork. What are the factors affecting what type of concrete you are using, whether it's reinforced or normal concrete? What exposure is it? Is the once you constructed, whether it's exposed to complete dry during its it's very risky and challenging if you do concreting in Dubai. That too, the people who are working during fasting month, it's killing life for them. For your information, I heard many stories from our students and those who presented these types of construction work, going for what co-op. You call co-op. We call this industry training. Industry training. Those who have gone for industry training, gone for doing their project at the site, they really had bad experiences and seeing all these types of construction work, especially concreting during daytime, because in the Middle East and hot countries, because the concretes were drying very fast, they work overnight. They never go for daytime work. They always go for nighttime work, so that the settling time is slow, not very fast, right? Because you need to give proper settling time for concrete to settle in order to achieve the required strength. Quick settling, there are quick settling cement, but it should not dry even once you open it, once you pour it, right? That is a required time. What you call settling time is permitted settling time should be reached for a given grade. And in Middle East, it will dry very fast. And fasting month, the people who are under Ramzan, the Muslim festival, during that they are fasting, they are still working overnight to accomplish their work, so that the daytime can be used for other types of clearing, loading, stocking material, and office works. They manage that way. Okay, so concrete type is important, the weather is important. Any subsequent treatment to be given to the concrete. We have time, right? For 1 more minute. Okay, the method of curing. Whether you pour water, you stack it with water, or you just put all the wet coney sacks, right? How you are going to cure it, depending on the curing method also, it varies. The spacing should be 1 meter center to center. I will explain this in diagram in next class. It's better you understand by diagram how the spacing of the 1 meter center to center is center to center, and this one is center to center is maintained. This is scaffolding, right? This is scaffolding, and this one we can call this as a spacing. The spacing between one scaffolding to another to another. This is called scaffolding spacing, 1 meter center to center. I will show in another video that is very clear. Stay last slide, just last slide. Formwork. Any other? I continue in the next class. See, like this video, I posted many videos. Please go through these videos. Very informative. I have given very selective one. There are millions of videos available. People posting, but you go at least the selected types, which is appropriate and according to your syllabus. I posted here. Any question? I stop here for today's class. We continue next class. Please keep posting your feedback. I don't ask every class, but if you find anything useful, anything I can continue using, please mention. If any correction needed, any requirements, you please mention that as well. then and there. Okay. Okay, I stop here. Any question you can ask.